Hey Comets, welcome to another day of learning. Hope you're doing well. Today we're going to do page 3 of week 5, and it looks like this. So yesterday we talked about distributive property. Today we're going to do the opposite of that. Okay, we're on this page here with factoring. Okay, so we can also write equivalent expressions using factoring, where the distributive property has us multiply into the parentheses. Factoring allows us to pull values out and create the need for parentheses. Okay, so this may seem a little bit weird, right? We're simplifying by doing the distributive property, and now you're asking us to undo it? That's kind of weird. Okay, well, I know, but this is useful later on where you can use this to simplify things, and it's actually pretty helpful. And if you remember, when we were talking about GCF and LCM, we were talking about factoring trees. We pulled a number apart. Okay, that seemed backwards too, right? Because you're used to multiplying things together to get a final answer. There you were pulling things apart. All right, that is part of math. Okay, it's this analysis synthesis thing. Okay, big words, but they basically mean pull apart so you can see more detail of something, and then you can kind of put it back together in a different way. All right, it's a big part of the process of learning. Okay. Anyway, off of my little theory soapbox here. So let's get back to the math. Example, use factoring to write an equivalent expression to 12x plus 18. So 12x plus 18, we need to think, all right, what's in 12 and what's in 18 that they have in common? Okay? So in other words, what's a number that I can divide 12 by that I can also divide 18 by? Okay? 2 probably comes to mind, right? Because 12 is an even number, 18 is an even number. I can divide them both by 2. Okay, that's good, but can we go bigger? All right? Well, notice they said 6 is the GCF. So they put 6 out here, all right? And you write it on the outside of the parentheses, okay? So you write that out here. Then you ask yourself a question. What times 6, since that's the number we pulled out, would give us 12, and specifically 12x, all right? Well, what times 6 gives us 12? The answer is 2. So I would put 2x. Because if I did it backwards, I would do 6 times 2x would give me 12x, which gets back to here. Okay? You should always be able to multiply and do the distributive property to get back to your original answer. That's if you did it right. Okay? And then what times 6 gives me 18? The answer is 3. So this is our final answer. Okay? And again, if you want to check, you can always multiply that distributive property and see if you get back to your original answer. If you can, you probably did it right. Okay? And that's factoring. Okay? So for each question, use factoring to write an equivalent expression. Okay, so let's look at A. 10 plus 15x. Okay? Take a closer look here. All right, 10 plus 15x. Well, I need to look at the 10 and I need to look at the 15 and ask myself, what do they have in common? Okay, first thing that comes to my mind is 5. All right, anything bigger than 5 that goes into both 10 and 15. Can't think of it. All right, 5 goes into 10, 5 goes into 15. So 5 is what we're going to write on the outside of my parentheses. And since there's an addition here, I'm going to put addition down here. Now, if this is subtraction right here, I'm going to put subtraction down here. Okay? So 5, so now I need to ask, so 5 times what gives me 10? All right? Well, 5 times 2 gives me 10, and 5 times 3 gives me 15, so it's 3x. Okay? So we're pulling out this 5. It's kind of like the extractor on Monsters, Inc. You know, like, they're pulling the screams out. Okay, they're pulling out a 5 from the 10, so what's left over is a 2. They're pulling a 5 out of the 15, so a 3 is left. Okay, and this is our answer when we're factoring. Now, if we were simplifying, we would want to distribute this. Okay, but that would be going backwards. We don't want to do that. All right? So that's how we would approach these problems. Find the greatest common factor, pull it out on the outside of the parentheses, and then inside the parentheses write what you would need to multiply it by to get those numbers. Okay? All right, writing expressions from words, okay? A lot of words here that mean things like addition, subtraction, multiplication, division, okay? Or a variable, okay? Something we don't know. All right, so kind of use this code here as you translate. And we sometimes are given a word phrase, we need to translate it into an expression. So translate the word phrase into an expression. 1/2 of a number plus 12. Okay, 1/2, we got that, right? That's a fraction, okay? Of always means multiply. I've yet to find a time when it did not mean multiply. Okay, I'm still looking. All right, I'll let you know if I find one. 1/2 of, so multiply 1/2 times a number. Do we know what that number is? No. And like it says over here, a number means a variable. So you get to pick a variable. They chose x, that's fine. You can put a different letter in there. So 1/2 times x, and then it says plus, which we know plus means addition, plus 12. So write that there. So 1/2 x plus 12 is how we would write that. Okay? Now, we're going to try A together. A says the product, okay, there's an indicator word. Product means multiplication, right? Right there, product. So the product of 9 and 6. Okay, now I know the order is weird here because they say product first and then they give you two numbers. Okay, so does that mean you put times 5, 6? Oh, definitely not, because it would be 9 and 6. No, the product means, okay, I'm going to tell you two numbers, and I want you to find the product of them. So find the product of, and then these two numbers. So put those two numbers in. That's what you want to find the product of. So 9 and 6, and then minus an unknown. Okay, what does unknown mean? Well, it's a variable, right? So we're going to then take away an unknown number. I'm going to use n. All right, so let's take a closer look. We got the product of 9 and 6, and then we're going to minus an unknown. All right? So that's what we would do for A. Okay? So that's all we're doing there. We're taking this word phrase and turning it into a numeric statement, expression. Okay? That's where we're going to leave off today. Thank you guys for watching and engaging the math. Tomorrow I'll be posting the last page of the week. Again, thanks for watching. Bye.